So, and then there are some things we haven't talked about and we did not do a good job on yesterday that we need to rectify today. Well, rectify in the future. We won't actually rectify it today. Okay, yesterday was our first official AP test. And then it drive me crazy. Yesterday was our first official AP test. And the truth is we didn't do exactly what we're supposed to do. Next time it'll be timed. So those who didn't finish, that's not going to be an option. Like, it's going to be that you have 13 minutes to finish this problem, this free response problem, and you don't have any longer. Because I know that's stressful, but we've got to get used to that. That's how it is on the test. You have this long, and you must get the things done. Okay, I handed you a cute little handout the other day. It said AP Stats Exam Tips. It looked like this. And it told you that the actual exam has 40 multiple choice. But you have 90 minutes. So what does that mean? How much do you have per question?
A little bit more than 2 minutes.
So it's a little bit more than 2 minutes. So really, we had 8 questions yesterday that were multiple choice, and I let you have one person took like almost the entire class period. Really, I should have given you 16, 17 minutes tops. That's it. So just so you know, I was nice this time and didn't enforce the time rule. From here on out, we're going to be strict because the exam is strict. Okay, as for the free response, the free response has 5 questions, but it also has one investigative task, which we're not even going to touch with a 10-foot pole right now. It's where Louise needs to design his own experiment, show all these things. Like, the investigative task is going to take a good chunk of his 90-minute time on that second portion. So really what it ends up being is we decide you get about 13 minutes max, per free response question. So basically, if it took you longer than it took till 3 p.m. yesterday, you're taking too long, we got to pick up the pace. So, just wanted to say that. The next test, it will be timed. There will be no coming zero period because we're going to get it done in a certain time limit. Now that we all have a textbook, we can actually follow this thing. Yeah, we all have a textbook now. Have you even made it? Yeah, we all have one. So we can follow this thing. So today is day 1 of chapter 2. So if Ashley's trying to not have to do 1,000 problems all over again, tonight she'll go ahead and get those problems done. And honestly, it would be smart. Every night you only have like 6 problems. This would be much better now that we can actually follow the track. Life will be so much better. Okay. In theory.
Are we taking exactly how many days for this?
Yes. This is exactly what we're going to do. You could pinpoint when the test is. Yes. If today is... Mm-hmm.
That's Monday weekend, right?
Well, yeah, I mean, obviously we gotta take off Monday. So if this is Tuesday, Wednesday, Thursday, Friday, we're off Monday, Tuesday, Wednesday, Thursday would be the test. Okay. No, sorry, we can count. We got this. Okay, I do have those quizzes to pass back. Most people did well on their second quiz. If one more person, however, tries to tell me that the mean is resistant, I might cry, but I'm going to work on it. The median is the one that's resistant. I've had 3 turn in their homework. I'm missing a lot of homework, and don't worry, I went ahead and typed in the 0. Whereas my homework, I need it. You didn't give it to me, you better make sure it's in my hands tomorrow, because guess what? Progress report's coming out on Friday, and everyone's going to know you didn't never turn in that type of homework. Just so you know. I have some people who did over the amount again, so there were only 29 problems to assign. They did 36. They got 36 points out of 29. They went ahead and got a bonus for that. It's not a bad idea. Now, if you absolutely cannot, it's only in the 10% category, but how on God's green earth are you going to do well on a test if you're not practicing on your own? You are very smart, but just absorbing my words is not enough in life. Okay, backing up to this. So, this one. So I'm saying your test is out of 16 points, 16 total points. So if you had made 100 on the multiple choice and 100 on the free response, you would get a 16 out of 16. I'm doing 50% with each, so that means 8 points with each. So I've already graded your multiple choice. No one's at the 8 out of 8. The highest I've seen so far is a 6 out of 8.
Okay.
Now, that sounds scary because you're like, that's a 61.24. Oh my goodness, it's confident. But let's be honest, If we add 8 more points, we're at 14, so we're going to end up in a 94.
Let's assume you get all those right.
That's assuming you get all that right and you used your words well, we should see.
Which I did.
If you didn't, so you're somewhere in between probably the 60 and the 90, which is per usual in life, somewhere in between the 60 and the 90. So I just wanted you to know that there was no one missed more than 4. So I know that sounds sad that made me happy, but that made me happy that no one missed more than 50%. Okay.
Not even
The most missed question from the test yesterday,
number one.
which seems kind of cheaty since one of us hadn't seen it, but anyway, would be the well, no, because I talked about it yesterday. The question that involved a histogram and asked you about Q3. That was the most missed question. The people who did get it right, you know what they did? What did they draw? They drew a box plot to reference really fast. From the histogram, they drew a box plot, and that helped them figure out exactly where Q3 was. That was smart. Okay, we can, if you want to, I'm going to tell you all the answers.
I'll be off.
No, not right now. I'm going to tell you all the answers. Well, Jane is not taking it either. I'm going to tell you all the answers once we have 2 more people left to take it. As soon as I get them all done, I'll give you all the things, and you can keep it forever. I know that sounds strange that I'm going to let Louise keep his chapter 1 test forever. I normally keep everything on file because I'm a hoarder, but I want him to be able to reference it in life. Okay. And then I have one person who didn't realize that there was a back to the free response. So it's you, Sally. You knew there was. No, I didn't finish. You just didn't finish. Was there anyone else who just didn't finish? I just thought you were back. Okay. Otherwise, but at first glance, they look pretty good, but we shall see. So somewhere between a 60 and a 90, as is per usual in math class. Moving on today to bigger and brighter things. We're now moving on to the next chapter, which is chapter 2.
Does all the AP have the same scaling?
No.
So like, I know AP carried last year.
I don't know if they, this is the way the lady at my training did it, and I liked it. It makes sense to me. So I'm really bad.
This with the grace, I think it's a big scale.
Vanilla does a different scale.
No, with the grace, Miss Holbrook's.
Holbrook's is the scale.
Or KB chemistry, she
Okay.
has identified.
Okay, well, I don't want anyone, this prevents people, as you'll see, it prevents people from crashing and burning. But it hurts those who are at the top because it's hard to climb even further up the top. That's kind of the whole point of your project, as you're figuring out, hopefully, the grade. Yes, dear. Yes, dear.
And then something
Yes, dear.
really stupid. I took a test yesterday, obviously, but like on my project that I started, I got stuck as soon as it said outliers because I got confused again. So
Remember we had that 1.5 IQR rule. So did you do,
yeah, I just was like confused on the fact of when you got the number, was it like that? I don't know how to explain it.
okay, so let's say you calculate this and you get 175 for that upper bound. So if you have any number that's bigger than that 175, so 175 for instance is less than 200. If you have any number that's bigger than that 175, it is going to be an outlier. If you don't have,
that you're finding is an outlier because I thought it was like, well, my thing only goes up to 175, so it's not an outlier.
okay, so we're going to call that, really, I guess we should be more specific. I'm calling that the upper bound. So anything beyond that is an outlier. So if we, that's kind of what the whole point of the box plot was.
I thought it was when that number was bigger than what I'm getting.
Yeah, if the outlier is bigger than that, it is an outlier. Yes.
No, like the 175, like I thought if the 175 was bigger than, what am I trying to say?
Okay.
You know what I'm saying? Okay, so like the Q3, you find the outlier thing, and I thought if it was like the former number, like the max, okay, so the max, if you have a maximum,
Okay.
and 175 is bigger,
Then you'll know you have an outlier. Well, you'll know.
175 is-
Okay, so if your max was 100,
Yeah.
but then you had a value over here at 200, and then you and I did this test that said we're not accepting anything over 175, that would let us know 200 is an outlier. I don't know if that helped.
No, because that means I just got like everything.
If we use this formula, we get an upper bound. Any number over that is an outlier. In the same way we use the Q1 minus 1.5 IQR, any number below that is an outlier.
But what if it's not? So that it's not an outlier.
It's not an outlier. And then we would say it's, you could just say it's at influential points. You could make it sound like it's an important point, but you can't call it an outlier, because if you deem it and call it an outlier, you better have some math to back it up. In fact, I think Kenzie, in her test for cussing, there was some data, or it might not have been her, it was someone on their quiz, they didn't get that there was an outlier in their on a previous quiz, and there was one. But since they didn't get there was an outlier, when they got to unusual features, they couldn't say anything about an outlier. So they talked about the spread and how there were quite a few points here or there. Like, I don't know. They talked about the spread of the points instead of an outlier. It wasn't stupid. It was really a good save. You know, like, and that was the whole point. And I think it was you. And if you don't mind, I'm going to show it. Where is my stack of stuff?
Oh, thanks.
I don't know. I'll come back to it. There was a person who did it on their quiz, and that reminded me. No, Jackson does not use his words, but he does all his math. It wasn't Ashley. It wasn't Alex. It's not Jackson. It's not Jared. It's not Kenzie. Bless you.
I just spit out my water and I didn't want to hang out. Oh my gosh.
Sally. It's Sally.
Oh, it was me. Okay,
Okay.
nice.
It's Sally. Okay, so Sally.
Welcome to making mistakes.
Sally, and back to on the actual exam, on the actual AP exam, never in their life are they going to give you that many data points to type in. Because Sally was in a hurry. She didn't type in the last one, which sadly was the most important one because it was an actual outlier. So I knew something was going on when she didn't have the 151 on her modified box plot. So then, when it said, are there any outliers, she said, well, no, there are no outliers. So instead, she drew me a dot plot of the data, which I thought was smart. And then she had to talk about the gaps and how it's sporadic. I'm going to talk about how to spell sporadic another day. Anyway,
Oh,
she
wait,
talked
that's
about,
the other one?
Yeah.
Sporadically? Oh.
yeah, we're gonna. Well, I don't know. It's back to cursive. I don't know if they're O's or A's or anyway.
They're A's.
Okay, we'll work on that.
Okay.
So she couldn't reference an outlier for her U, so she said gaps placed sporadically around the graph. So just because she messed up at the top doesn't mean I have to count off from there on out. I have to roll with what she has, and did she use her words right for what she had? Hence why they're never going to let you type in all the stuff, because they don't want to have these separate rubrics for what if Kenzie forgets to type in the one number. Okay. Now that
It
me and
was so
Olivia...
hard to cover the score of the game, then you just showed it.
Oh, well.
I don't care.
It was good.
Actually, quiz?
You can, when I get done ranting. Okay, let me rant about chapter 2, unless you got something else to ask, Olivia.
No,
But that's-
it's just
was that
like,
sufficient?
I don't know why I'm not thinking about it, because it's just like whenever it's bigger, I think the opposite. It's like it's not an outlier, because if I have like 135, not 175, I don't want to, I don't know. Like, I figure like it's the number within the box plot, not the outlier.
I've not noticed you doing it wrong, and I've read a lot of your work lately.
Okay.
But I'll let you know the second I
Like,
see it.
I just got stuck when I was doing the
Test?
for it.
Okay. Okay.
No, like the project.
Okay, you want me to look? I'll look at it when I get done rambling. Okay.
Okay.
Today we're going to start chapter 2, which is really exciting. We're going to talk about a Z-score. Tomorrow we get to standard normalized stuff, which is where we live in stats. So today we need to know what is a Z-score. It is a standardized score that measures... I'm sorry, Sally. I really meant to cover that up. I hate it when people know all my business.
Do what?
I really meant to cover that up.
I don't know, I don't care.
Okay, it's a standardized score, good, that measures the number of that thing you hate already because you don't remember the formula, but it's on your formula sheet and your calculator does it for you. Standard deviation from the mean. Can I what? I can do better. Okay, a standardized score that measures the number of standard deviations from the mean. There should be an S.
I'm sorry, sounds so stupid saying it out loud, but what does standardized mean?
It's been normalized, and it's not a stupid question. I swear, just let us keep talking, and eventually we'll be like, okay, standard means normal. Okay, so we're trying to measure how many deviations we are from the mean. So how far did we get away from that true mean? And again, the mean could be skewed if our data has outliers, but what we're assuming right now is we got some nice pretty stuff, we pray. Okay, and then I'm going to write a little side note to myself. The sign plus or minus gives the direction. Okay, and then so we do need a formula, and I'm questioning myself if it's on your formula sheet. I really don't believe it is. It's x minus x bar. Remind me what x bar is. The mean. And it's divided by s. So x is going to be our specific data value, like a specific point. X bar is the mean. And then this chapter, I'm probably going to try to refer to it more and more as the sample. It's the sample's mean. It might not be the mean of everything in life. And then S is for the standard deviation of the sample. I can't spell. Okay, so our goal is to make a 5. One way to not get a 5 is to put units on your z-scores. Z-scores, when you calculate them, do they have units? No.
No.
Don't have units. So don't say it's 2 inches away from the mean, 3 inches away, 5 inches. So do not put a unit on it. And then this might seem like a dumb question, but I like it. It says, what does the sign of a standardized score tell you? And it tells you the score is above if it's positive, or below, like positive, negative.
Okay.
The score is above or below the mean.
I'm not above.
And then, like everything else we've done in stats, a whole lot of words, none of them really make sense until we actually try it with an example. So, we wrote this really long scenario. The single season home run record for Major League Baseball has been set just 3 times since Babe Ruth hit 60 home runs in 1927. Blah, 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 baseball. Something, something, something. To make a fair comparison, we should see how these performances rate relative to other hitters during the same year. Calculate the standardized score for each player and compare. Okay, so we've got to calculate the z-scores. So again, we have that formula that says we're going to do x minus x bar divided by s. Thank you, dear. Thankfully, we're given all these things. So x is the sample. It's going to be 60 minus x bar. Well, that's 7.2 divided by s. That's going to be 9.7. When you type that in your calculator, I need it with 2 decimal places. We did x, which was the sample, minus x bar, which is that mean, all divided by that standard deviation.
5.44.
Okay, 5.44. Again, this number is telling us the number of standard deviations we are away from the mean. And that's a really big number, and that makes sense because 60, isn't that super far away from 7.2? So that kind of makes natural sense. Okay, let's do the next one. So my sample is 61. That average, the mean for this one is 18.8. The standard deviation for this one is 13.4. And why is it changing? Because we're doing different years and different samples. Okay, so what should my next value be? 3.15.
Wait, okay, where do you find the standard deviation?
The SD.
No way.
And when you do the 5-number summary,
What's that little symbol?
so stats, and then you press calculate when variable stats, and then it gives you S of X and then the omega x. Normally we're doing S of x, unless they tell you the whole population, then we'll be doing the other one. So normally it's S of x. That's why we're using S's here. S for sample. Okay, and then we're still doing the same old process. My sample minus my mean divided by my standard deviation. So 70 minus 20.7 divided by 12.7. And what do you get?
3.88.
Thank you. And then last but not least, 73 minus 21.4 divided by 13.2. What do you get? 3.9 what? Thank you.
You know what, dude? One second.
That's what I have it at 3.88.
Lamar.
Okay.
I'm gonna assume I did 98. Right.
Okay. So we did all this work. We filled in this category for Z-scores. Now we got to do something with it. So it says in 2001, some player, Arizona Diamondback Mark Grace's home run total has a standard score of Z equals negative 0.48. Interpret this value and calculate the number of home runs hit. Okay. We can still calculate this. It's supposed to be Z equals X minus X bar over S. They told us the Z, didn't they? They told us the Z, so that's negative 0.48. We don't know the X, but we know the X bar and the S. How do we know the X bar and the S? How does it tell? Where does it tell us on the chart? Yes, because this dude did it in 2001, so let's use that information from 2001. So X bar is 21.4, and the standard deviation is 13.2. Perfect. Okay, you took math class and somehow made it this far. How do we solve this equation? Okay, so multiply both sides by 13.2, and you should have negative 6.34 equals X minus 21.4. Now add 21.4 to both sides. And don't actually show this in real life, because surely you did that in your head, but I don't know. I don't know you that well.
0.06.
Is it 0.6?
Yes.
Cool. Okay, we've got a number. Yay! We calculated the number of home runs hit. And Jackson is very good at this. He's good at calculating things. However, there's one thing I would get on to him for on his last quiz. It's the part where they want you to use your words, like when they put justify or interpret.
I have a
We're
question.
gonna, yes, dear.
Is this an actual Jackson thing, or is it that thing where you just got?
No, it actually is you.
Oh, dang it.
Like, you did a good job cussing, but could you use more words? Yeah. Like, you give me the bare minimum. Yeah, you need to cuss more.
I do that.
Okay. So we need to interpret this. So what does this
A
mean?
little more.
What does this mean? What about Mark Grace's home run score?
I don't know. I'm not with my words.
Grace's home runs are what?
Well, you're on to something for a second.
Because home runs are less than the average. Is that
We got that, yeah.
before?
We can say that last. And, yeah. Well, I mean, we knew that when we got 15.06 and the mean was 21.4, or less than the average. I'm running out of room. And then if we needed to, like, tell it to ourselves, we're like, yeah, because 15.06 is what he got. It's less than 21.4. But then the whole point today was to understand what a z-score was. So what I would say is that I'm going to call him MG. MG's home runs are, and I'm just going to reference that standard deviation, or that z-score, sorry, are 0.48 standard deviations below the mean in 2001. Okay, So we have Louise's sentence, because he doesn't know.
You just got, MD's home runs are 48.
Standard deviations below the mean in 2001. Okay, so I wrote, really ugly, you're driving me crazy. I wrote Mark Grace's home runs are 0.48 standard deviations below the mean in 2001. Okay, why would my sentence technically be a little better than Louise's sentence? Yes, dear.
Could you say instead, due to the fact that the X, actually no, yeah, it's an underscore. So the Z-score is
Yeah.
negative, so you would know it would have to be less than the average. Is that how that works?
Yes, because the Z-score was negative, that's why we knew it was less than the average. So if you'd somehow made a reference to the Z-score right here, so less than the average, and then say Z-score, like somehow reference it in your sentence, that would be better. Again, so we had this negative Z-score, so we should have known to begin with, he's under par because he has that negative Z-score. So that's why his is so many below the mean. Okay, and then back to Louise pointed out the other day when we were practicing free response, I've done something in my answer that technically didn't happen in his answer.
You referred back to the poll. I kind of did.
He kind of did by saying Mark Grace's home runs, but notice I even included specifically we're only referring to 2001.
Okay.
And I know you're like, Miss Compton, that kind of context is being ridiculous. But let's be honest, we want to further justify we're only looking at the 2001 list on that chart rather than everybody, including like Babe Ruth. Okay, and then I'm running out of room. I shouldn't have written all that stuff. I need to write this one under here because I can't fit it. So a large Z-score indicates that a value is greatly above or below average. Big Z-scores scare me. That means we're either super above the average or we're super below the average. And I'm even going to put numbers on it. We're freaked out by Z-scores that are bigger than 2.5, and we're also freaked out by ones that are less than 2.5. So there is a number. If you see a Z-score that is bigger or less than that, it's concerning.
Concerning as in we did something wrong?
Concerning as in something going on with that data, because why are their points that far away from the mean? That probably means there's an outlier. It probably means you're skewed. And again, what we pray for desperately is life would just be symmetric. So the smaller the Z-score is, the closer the value is to the actual mean. We like small Z-scores. For instance, this was really small, negative 0.48. That's not a very big number. And his 15.06 is really not that far away from 21.4 in real life. That's not that many more home runs.
IRL.
And then, my gosh, we wish we had a Z-score that was 0, because if it was as close to 0 or really close to 0, what would that imply?
Really close to
So it's equivalent to or as close to the mean as we can get. So I'm going to say equal to the mean.
Negative 0.4 is good Z-score.
Yes, so anything between 2.5 and negative 2.5 we're okay with. In fact, we're about to learn how to read a table with it yesterday.
So that part in the parentheses right after greatly above or below average, the bottom one, is that supposed to be negative 2.5?
Yes. Bless you.
That clarifies everything.
Okay, so sorry baby, you know my words get in a hurry. So we're happy with stuff that is, like the negative 0.48 was good. We'd be concerned if it was negative 2.5 or bigger. So negative 3 would be concerning. Because it's saying that's how far away we are from the mean. And then back to when is a Z-score considered large? And that's when we're going to use that 2.5 as a reference. Positive 2.5, negative 2.5, anything bigger or smaller than the positive or negative version of 2.5 is a definite concern in life. And when I say concern, all that means is like Mackenzie was saying, you should look for an outlier. You should ask why this is going on. You need to start asking some questions. Okay, flip over. So now to talk about, now that we've kind of covered Z-curves, and I swear there's more to say, we're going to talk about a density curve. And it's actually in your textbook if you want to read more up on it. I highly recommend that. So a density curve is a curve that is always on or above the x-axis and it has an area of 1 under the curve.
A little more.
Okay, so a density curve is a curve that is always on or above the x-axis. We can see a few examples about to come up. And it has an area of 1 under the curve. Now, to me, it looks really similar to a histogram,
Oh, those are the bar graphs in touch.
the bar graphs to touch. It looks really similar to that, especially when they start drawing in lines underneath. That's what it starts to look like to me. But it is different because it describes the overall pattern of a distribution. Not annoying at all.
You're talking to me?
Yep.
I'm sorry.
It describes the overall pattern of the distribution. And what makes that different is that unlike a histogram, because it gives the exact distribution, unlike a histogram.
I'm sorry if it's talking.
It's okay. I'm used to you distracting me.
One more.
It's like Lamau, except not LMAO. Doesn't mean anything. It's just
Yeah, it's-
similar.
yeah.
It's just a lowest thing.
Accurate.
Aggregate.
Okay, so we're about to practice reading a density curve, and it's different from a histogram because it's describing the overall pattern, whereas the histogram gives the exact. You know, a histogram, we had it, if it veered, we veered, whereas this is just a general thing. And how can you identify the mean and the median of a density curve? The median equal areas point. And the mean, we tend to call that the balance point. And you're like, what the crap does that mean, Miss Compton? But I swear we're going to get there.
Also, what does standardized mean? Yeah, and she's still not an answer. You just had to figure it out when that happened.
If we standardize something, we make it normal. We turn it into normal data. Making it normal as in we take it and we try to make it symmetric and try to make it fit the way we want it to fit. And we do that all the time.
That was
That was the best I can give you at the moment until we get further along in life.
A lot.
Okay. That's the best I can do at the moment until we get further along in
You
life.
did a great job.
Okay. I appreciate that. Okay, you're like, Miss Compton, I have no idea what that means. You wrote median, equal areas point, and mean means balance point. I don't know what that means, so I swear we're going to get there with our next two examples. So, we see that they've given us these two density curves, and they've asked us to identify the mean and the median on the density curves below. So, is this graph skewed left, skewed right? What's the deal with A?
Right.
Okay, so it's skewed, and I'm getting lazy. It's skewed right. And then what about with B? How is it?
Symmetric.
It's symmetric. Okay, I have some people putting it's perfectly symmetric. Be very careful when you start putting words like perfect. I would even say roughly symmetric. Nothing's perfect in life. Nothing's perfect. Okay, so
Except for these.
we know if it's symmetric, what happens with the mean and the median?
it was similar, close,
How similar?
almost.
What if it was perfect?
That makes
Okay, if it was perfect, then they would be the same. So the mean would equal the median, and where would that happen on this graph?
in the middle.
Which is what letter?
A.
Okay, so the mean and the median would happen here in A. Perfect. Meanwhile, over here in skewed right land, we realize that the mean is it greater than, less than, or equal to the median?
Mean is greater than.
It's greater than. It's greater than. That's good because of those extra data points, those outliers over here that are pulling it that way. And then if we had to pick a point to label for the median and a point to label for the mean, what point would you label with the median, A, B, or C?
Probably A.
You can say A, B, or A. Or A. Either one. We assume it's somewhere in there. You and I are just guesstimating. We don't know.
Like, I'm totally lost right now.
Not even played that.
I'm trying. I'm really trying.
You know, I've not gotten mad in any class. I would hate for the one class I get mad into the AP stats.
I'm sorry. It's just you said meanwhile and speed right, man. That made me laugh.
I'm glad you appreciated my humor. Okay. I'm going to need y'all to use words, because if you're confused about why they're skewed right and why they're symmetric and why the mean's greater than median and mean's equal median, then we got some chapter 1 problems. We don't have chapter 1 problems, do we?
I think we did that, but I don't understand why we're learning that.
We're trying to do it with a density curve, because a density curve is technically not a histogram, so we've got to be able to identify where we think the mean and the median would be on a density curve.
So what makes it the density? Is that like the line?
Again, the fact that they've drawn that overall pattern. Remember when you were doing it and you had like when you did it over your histogram and you ended up having like a ugliness? They've made it unugly, haven't they? So their data might actually be ugly, but they made it this way. It might look more like this, but they did that. So that's going to be the difference between a histogram, which is exact, and this density curve where we're like, it kind of looks like it's that, and so therefore it's that.
I guess so mine might be with the chapter 1 thing. So mean equals median because it's symmetric.
Yes.
Symmetric means equal.
Yes, the mean and the median should have it at the same spot. Yes.
And then mean is greater.
Because it's skewed right, so that means there are outliers over here, right?
Yeah.
And the outliers are affecting the mean, right? So the mean is going to be a bigger number than that median. Whereas if it was a graph like this, where we were having really small numbers, those really small numbers would bring that mean down, whereas that median is still going to happen in the middle.
It's the same.
Okay.
Okay.
So it just depends on how it's skewed, affects darn back to the median not being resistant.
So what's up with the B or A? What is,
So they've drawn in these,
that's just like the B on here, not like the
Yes.
B and A. It's a different.
yeah, they're talking about B and A on here. If we were estimating with this graph, with those 3 points, A, B, and C, would we label A as the median, B as the median, like who gets to be the median?
Can you put that, or is that like wrong, or because I mean it is like a B or an A? So that's,
So, no, in fact, in my notes I wrote either one. So we're not sure. In fact, we'd have to be given actual data points in order to calculate the median. Again, if we don't have actual data points, we're just estimating, making a good educated guess, but just estimating. Ma'am,
What is, I can't see it, so what is the median, what does that say? Like, what do you put equals what or?
B or A. I said point B or point A. So over here, we're not sure if this one or this one are the median. We're not sure. Okay, and then back to the mean, we understand that since it's skewed right, that mean is further over this way. So if we had to guess who was the mean, we would say it's C, or if we picked A for the median, what would also make sense for the mean? Or B. It just depends. If we pick the median to be B, that mean has to be to the right of it, so the mean has to be C. If we pick the median to be A, the mean has to be to the right of it, so it could be B or C. We're just not sure. Again, we're just estimating. A density curve, the whole thing was that they took this and they turned it into that perfect thing. Okay, we got one more left, and then we're on day 2, which is normal distribution. So one more. It says, using the uniform distribution below, find the area. So notice how it's made this perfect uniform graph, which we haven't really got to practice with, so this is good. So they've told us 0.5 is here. Find the areas. And it says, how long do I have? I don't have, okay, we need to come back to this one tomorrow because it's 2:55 and I need to give Louise this stuff. And Louise and people need to give me their quizzes and stuff. Not quizzes, homework and stuff.
Do we see our grade on the multiple choice?
Absolutely. Sally. Louise.
Skewed right now.
Olivia.
I'm sorry.
Talia. I want some management. Kenzie.
I don't know why I found it so funny.
Jared Jackson. Jared. Alex.
That's actually surprisingly better.
Ashley. some get over a perfect score on that 60% grade, which means they have over 100 at the moment in my class. Amazing. Olivia Dana's not here. Kenzie. We passed that over to Kenzie.
Since you threw it at me.
Hunter, thank you.
I'm like so in
Olivia.
shock right now.
Are some of these,
Samantha. Batman. Hunter. Ashley. Sally.
What'd you get?
Kenzie, thank you, Ashley. We passed that over to Kenzie. And then Jane is still not here. Okay. As for the multiple choice, I can't let you keep it because I have some people who haven't had it.
wait, what'd you just get back?
The quiz.
What exactly? I have a question.
Sally.
On the quizzes, so when it says.
Those are the answers, they're yours, just come and email.
Is the plus one, is that like a bonus?
Yeah. It's like you use your words well, so you use it on it.
Why you giving me this?
On quizzes, I'll be nice enough to do that. On actual APs, that's no. Do you want to know what the answer was to number 5 that you missed? Or you don't want to know that right now?
It's mine, not style.
You know, I'm already in a different place in my head, so can I just look at another time? Because I need to come back to the test anyways.
You're on there, Sue.
Okay.
Okay. Ashley.
Will you be here in the morning for your hearing?
No, I'm running away from her.
Okay.
I think it means yes.
I'm still ready to practice.
Ooh.
I'm excited.
How much you get from
Yeah, that was wild.
Makes me angry. Makes me mad that I can't do
What?
that.
How would you?
We can keep the quiz, right?
No. The quiz, yes.
That,
You can use the quiz. Everyone's quiz, except Dana, and she's fine. It's quiz.
except that, whatever you're.
I have a different version.
Yeah.
So then it's just what did you make after that?
So even, wait.
So